Okay, we're going to talk about statistical significance, which is always connected to inferential statistics. So remember when we do an experiment, we always have a control group and an experimental group. A control group is given a placebo or simply not exposed to the independent variable. The experimental group is always exposed to the independent variable, right? So let's just say we have two groups here and we're doing a test on memory, right? And we want people to recall words. And perhaps we're giving this group some type of vitamin and we're giving this group, nothing, right? Or a placebo. So remember that we really want to figure out, did our vitamin therapy actually have a result, influence the results we're seeing? Because over here we're seeing that this group, our experimental group, did actually remember more words, right, on average, than this group. So we want to make sure, like, what role did chance play? What role did our vitamin play? So that's really how I'd want us to contextualize what we're talking about here when we're talking about statistical significance. Another way to think about this is to think about thresholds. And what I mean by that is you're familiar with thresholds in traditional grading systems where, say, the difference between a 59 and a 60 is a difference between passing and failing, right? So everything from a 59 and below is failing. Everything from a 60 and above is passing. Furthermore, we know that in traditional grading systems, the difference between this and this percentage is a letter grade, right? This would be a B, or some schools would have a B plus, and this would be an A. So for statistical significance, what we're really trying to measure in statistical significance, it's about the probability and the role that chance played, right? Just randomness, just a random differences between people, right? That has nothing to do with the independent variable that we're exposing certain people to. We're really trying to measure chance. I want you to understand what that means, right? Just randomness, right? Random difference. And we actually can measure chance, right? We can measure it by these tests, a chi-square, a t-test, and an ANOVA. You don't need to know how to do them. You just need to know that this is a mathematical process, right? And this is the key question, right? How can we be sure that chance did not play a significant role, play a role in our experimental results? And just like the idea that you need at least a 60% and above to pass a test, well, when you do one of these tests to measure chance, in order for the experiment to be statistically significant, scientists have decided that these tests, which provide us a p-value, right? And usually it'll be something like this, right? Which equals 5%. That the p-value has to be 0.05 or less. It can never be just zero. It can never go to zero. We can never be completely sure. But if it's 0.05 or 5% or less, then we would say that our results are statistically significant. So I want you to think about it. It's a threshold. So if your p-value after you did one of these tests, when you compared your experimental group and your control group results, or you can just say when you looking at the results of your experiment, if the p-value was this, we failed. That's failure. Okay? Our results are not statistically significant. Okay? So that would be 6%. We have failed. All right, so basically it has to be 5% or less, and that means that we can say that chance played a 5% or less role in the results. Therefore, they are statistically significant. Two ways of expressing this, if you saw this on a free response, would be this way. Remember, you can pause me at any time. Right? But what the AP is looking for is they want you to be able to express that statistical significance is a way of determining that the results are not likely to have occurred by chance, that they're just not random results. Well, if they're not random results, Why do we think we got the results we did? What do we think influenced the difference between the control group and the experimental group? Well, we think it was our independent variable. So statistical significance means that there is a high probability that the independent variable caused changes in the dependent variable, right? Now, when you're answering a question on the like an FRQ, because you're likely to see statistical significance either in a multiple choice or a free response, it's appeared in both, you would probably have to be more specific. What I mean by more specific is if the experiment in the FRQ gives you what the independent variable is, you might want to put the specific independent variable down and the specific dependent variable down, okay? But I would basically, define this and then just plug in the terms. But this is really what you want to communicate if you are answering a question about statistical significance on an AP FRQ.